Hi, everyone. We're going to go ahead and get started. I'd like to welcome you to our webinar, Buildings, Health, and Efficiency, How Lighting Controls Bring It All Together, presented today by BetterBricks, a commercial building resource from the Northwest Energy Efficiency Alliance. I'm Chris Meek, Associate Professor of Architecture at the University of Washington and Director of the Center for Integrated Design at the university's College of Built Environments. I'll be serving as your moderator. Thank you so much for taking the time to join us today. Over the past year, there has been increased awareness of the critical role that buildings play in our personal health, well-being, and happiness due to the COVID-19 pandemic. As we build back, many are now rethinking how to approach health in commercial spaces. Luminaire Level Lighting Controls are most often seen as an energy efficiency solution, on average achieving up to 63% energy efficiency, and a way to gain greater flexibility in managing a building's lighting system. Today, our presenters will be discussing how this technology also has the potential to revolutionize how we monitor and respond to environmental factors that impact human health and building efficiency. This includes a wide variety of applications, from asset tracking and ventilation to security and safety. Before we get started, a couple of housekeeping items. You all have been automatically muted as you entered the webinar. However, we welcome any and all questions. Please use the Q&A function on the bottom of your Zoom screen to send these our way. We'll answer some of the questions as we go along if needed, so feel free to send them at any time throughout the webinar. After the webinar, we'll also send a follow-up email with the webinar recording and slides. Today, we'll be starting off with introductions to our speakers and then providing an overview about LLLC technology and its high-level capabilities and benefits. We'll go on to provide historical context for the impact of buildings on health before jumping into several unique use cases for how LLLC can improve how we monitor and address human health within buildings. We'll wrap up with a dedicated portion of time for questions and answers. With that, I want to introduce our two presenters. Our first expert is Dr. Kevin Vanden Melenberg, Director of the Energy Studies and Buildings Laboratory at the University of Oregon. At the college, he also serves as Professor of Architecture and Director of the Institute for Health in the Built Environment. His expertise includes consulting on several hundred new construction and major renovation projects focused on daylight and energy in buildings since 2000. He also has published dozens of research papers and regularly presents at industry events. We are also joined by Alan Mahich, a research associate at the University of Oregon's Energy Studies and Buildings Laboratory. His work includes energy efficiency research, technical assistance, and outreach, and he has supported hundreds of research projects over the past 8 years. So now let's get started. Kevin will be getting us kicked off by sharing some background on LLLC technology and capabilities and the historical impact of buildings on health.
Hey everybody, it's really fun to see some familiar names in the attendees list. So hello to some old friends as well as to some new friends. Thanks for joining us today. I think this will be fun, hopefully interesting. It's going to cover a little bit of ground about where we are right now with Luminaire Level Lighting Control, how it works right now, and then a bit of vision, I think, about where it could play in the role of trying to improve healthy buildings, improve buildings for health, for human health in the future, and part of kind of reopen strategies. So with that, first, we got to start with the basics, which is what is a Luminaire Level Lighting Control system. I imagine maybe several of you have heard a bit about these, but essentially it's typically a LED lighting fixture with onboard photocells, illuminance sensors as well as occupancy sensors. So typically those two sensors onboard at each and every fixture. Wireless networking controls often, and the ability to have multiple control options, whether that's a smartphone app or on a desktop or certainly at the wall with typical wall-mounted switches or distributed remote switches. So a lot of kind of networked control options. Next slide. So what can we do with Luminaire Level Lighting Control, or LLLC, right now? Certainly occupancy sensing, that's kind of the core of it. This is, obviously an energy saving strategy to turn off lights when they're not needed. And this has, incredibly granular control because it's literally every single light fixture. The potential with the photocell, the illuminance sensor, to do daylight harvesting. So what that's doing is looking for the available daylight, and there's a lot of ways to set this up from a control standpoint. But basically, it'll be trying to differentiate the light that it knows it's outputting from the electric light fixture relative to the illuminance that it's sensing in the space, and therefore knowing the rest may be daylight, and then dimming to a specific lighting criteria accordingly. So the ability to do substantial daylight harvesting, and again, at every single fixture. So each fixture has its ability to sense the daylight just nearby and dim accordingly. The potential for continuous dimming from 1% up to 100% with pretty linear energy relationship there. And then from a user perspective, and this could be either handled by individual users at every single light fixture, or sometimes it's handled institutionally at a floor level or at a zone level. But the ability to do high-end trim, that means, for example, if more light is installed than is needed, you can immediately, shave some off the top and have really consistent energy savings just, by having that high-end ability trimmed back down to lighting criteria. And then individual task tuning. I'll make a mention of it here. A lot of the work about a nice report that we had something to do with, so I guess that's why I say it's nice. But we worked with Neon on a report for a 1-for-1 replacement. And a lot of times when lighting retrofits happen, historically, they've happened at a 1-for-1. They just swap one fixture out and put one new fixture in. And oftentimes, especially with LED lighting, that can lead to over illumination. With high-end trim, you can bring that back down and save a bunch of energy out of the box. I think we'll be putting if we didn't already, we'll be putting that link to that report in the chat. And then finally, controls persistence. The thing I wanted to mention here is just because of the distributed sensors, sensors on every light fixture, there's a great deal of redundancy. And if something goes wrong, you're not losing a whole floor or a whole zone or a whole wing of a building. You're just losing the savings from one fixture. And then potentially, the redundancy could be networked together such that it's going to follow the nearest sensor that's still available. Next slide. So what have we seen? And that the report I mentioned documents a lot of this. There are actually quite a lot of research reports available to show and justify the energy savings. The work we did here, we're removing T5 linear pendant mount fixtures. We did about a year worth of energy logging, and it's a north-facing space. Doesn't have huge amounts of daylight, but does have some daylight. And we saw in the neighborhood of 75% electric lighting savings through the swap from linear fluorescent to the LLLC. Flexibility and future-proofing. Enhanced lighting quality. The report actually documents human factors research. We brought a bunch of human subjects, students, into the spaces and had them evaluate multiple different LLLC solutions. I think we had 4 different LLLC solutions. We had a full redesign solution, and we had the current linear fluorescent solution. And across the board, all of the LED solutions, including the LLLCs and the redesign, were favored from a lighting quality perspective over the fluorescent. And there was no significant differences between the complete redesign solution versus these 1-for-1 replacements with LLLC controls. So people liked them. We also evaluated the installation process. We actually kind of watched the installation process, monitored it. We had a controls contractor here on campus who did the installations. And the long and short of that was the electrical contractor really liked the installation. It was pretty smooth and seamless. And of course, there are some pretty streamlined, prescriptive energy code compliance pathways with NCQLP approved solutions for LLLC. Next. So we're going to jump into a little bit of background, and then Alan and I will do some tag teaming on what kind of enhanced capabilities we see on the near-term horizon in regards to health for Luminaire Level Lighting Controls. But so next slide, what I just wanted to start with is to recognize that buildings do indeed shape human health. I think we've known this for millennia. We've placed our cities in places with access to natural resources, waterways for transportation, access to fresh air, access to food, access to clean water. And then of course, you know, several hundred years ago, and maybe not so long ago in some places, a place to get waste to be removed from our cities quickly. And then we spend 90% of our lives indoors now. And, you know, we're about 100 years into what I call the greatest experiment of human history, which is becoming an indoor species. And it's not a big stretch to imagine that the spaces we surround ourselves with implicate our health. We're all feeling that viscerally now with COVID-19. In fact, many of us are not going into the buildings where we normally were because of risks for health. So it's not a stretch to say that our buildings shape our health. And 100 years ago, we learned the same lesson that we're learning now, is that connection to nature. This is the influenza pandemic of 1918, and this is Alvar Aalto's Piamio Sanatorium. And really, it documents this notion of access to daylight, access to views, connection to nature, access to fresh air, spending more time outdoors, more flexibility of our indoor-outdoor spaces. And it really kind of, I can make the argument that the 1918 pandemic kind of kick-started a movement in architecture, which was about a lot of things, modernism, but definitely included an awareness of kind of human existence inside of buildings and a desire and connection to nature. Next. Perhaps in contrast, we can say postmodernism kind of forgot some of those lessons, you know, almost 60 years later. 1980, Michael Graves building. Here we are in Oregon talking about this building. You know, it was much more about exterior expression, less about interior experience. This building has historically been referred to as the world's tallest basement. It was, you know, a lot about energy efficiency, actually. And I think it's the version of energy efficiency that we need to be careful of. And in fact, buildings like this that had very little glass, that were very tight and sealed and minimized how much outside air was brought in, didn't support human health. In fact, it spawned a whole set of codes about minimum indoor air quality standards. And I don't know about you, but I'm not super excited about minimum indoor air quality standards. I want good indoor air quality. And so buildings like this kind of led to this phenomenon of sick building syndrome. And it was in part pressured because of the energy crisis in the the 1973 oil embargo and the spawning of energy codes and increasing pressure to make buildings use less energy. And many of you know, I'm a huge energy efficiency proponent. But the challenge, the imperative we have is to do both. Next slide. When I say do both, I mean save energy and support human health. I just finished teaching a class called COVID, Climate, and Community. And boy, there's a lot of challenges and buildings that are facing humanity right now that are sort of essential for our success in the future. And buildings are a huge piece of it. And I don't want to say like technology is the magic wand. I always guard against that. But the technology of Luminaire Level Lighting Control is a really interesting backbone or hub for this sort of smart building, and I'll argue healthy building future, where I think we can braid together the lessons about, you know, connections to nature and access to fresh air, so creating healthy environments that are supportive of human productivity, as well as being really smart and energy and saving energy when possible. And so sometimes energy efficiency and healthy buildings are at odds with one another, and sometimes they're synergistic with one another. And what we want to do is, you know, push more towards those synergies. And when they are at odds, let's say how much fresh air are we going to deliver? Let's always err on the side of human health, but let's deliver it as efficiently as possible. Next. So with that, I think we're kind of gonna queue up a few ways that we think this backbone of connected buildings, luminaire level lighting control, can be used to support health. Chris, did you want to help with a little transition here?
Sure, Kevin. Thanks to you for that amazing bit of information. We're going to pass it along now to both Alan and Kevin, who are going to be diving into use cases that are going to demonstrate the potential for LLLC technology to really change how we approach buildings and health.
Great, thank you. So welcome, Alan. I would look at these bullets as kind of the chapters or the sections. There's a paper that I think will be dropped into the link here soon that we just posted yesterday that tries to write a little bit of narrative around these concepts, coincided with this webinar. So Alan's going to unpack these more, but I just wanted to kind of give the quick overview, sort of say what we're going to say, then Alan will say it, and then I'll summarize it. So, you know, right now, luminaire level lighting controls are primarily about dimming with daylight and switching off with lack of occupancy, which is great, saving a bunch of energy. Some of them are also integrating plug loads where that occupancy sensor on your light fixture is now also controlling some of your selected peripheral devices, probably not your CPU, but maybe it could put it into sleep mode. But yeah, basically, if nobody's there, it's going to turn off the monitors, turn off the task light, you know, turn off the portable heater you have under your desk or whatever. Then the next step would be asset tracking. So this is the idea that because you have this distributed sensor network, oftentimes Bluetooth enabled or other communication technology enabled, you can start tagging other assets within your space. And now you know where these other assets are. And Alan will unpack that a little bit more. Optimize space usage. One of the examples that I've seen quite often is like, find me a conference room. And it'll look, the system is smart enough to know where people are, where people aren't, and it'll say, oh, you're looking for a conference room. Here's the nearest one that's not being used. Demand response, many of you, I think, because I see some of your names, you know, the energy efficiency landscape pretty well, and you know that demand response is a strategy for balancing load and demand and supply. And so basically this is asking buildings to dim or reduce their energy usage. And one of the ways that that's been done historically is to dim lighting. Maybe we can do that with greater awareness now and pick places where people aren't when we do that dimming, or fewer people are. And then finally, this opportunity of building integration. And I think this is where some really exciting stuff comes in terms of healthy buildings. So with that, I'm going to turn it to Alan and he'll unpack some of these and we'll do some tag team.
Thank you very much, Kevin and Chris. So to start here, we've listed these in the order of technological maturity, so the closest to farthest from realization. So we'll start with space utilization and optimization. If we can jump to this next slide. So the modern workplace is or has been becoming increasingly decentralized as workers explore these advantages of working remotely while staying connected via the internet. And this has been especially the case during this last year and a half. And this is just one example of how dynamic demand for space can fluctuate based on circumstances, particularly in the commercial sector. So it's been estimated in previous research that 30 to 50% of the available space in a typical office building can remain unoccupied over the course of a business day. So LLCs could certainly help track and optimize space utilization by giving occupants real-time feedback, and potentially even could be made to pass along alerts, building alerts or BAS alerts for space availability through the distributed network of occupancy sensors that LLCs provide. And this is often referred to as hot desking or hoteling of private and open offices, as well as other shared spaces like conference rooms and classrooms. So this has quite a bit of potential to reduce energy consumption by increasing space use efficiency. So basically, optimizing buildings or spatial use per zone, and being able to allow other zones to have a wider temperature dead bands and avoid tripping other occupant-centric energy loads in the process. So this first slide here is just an example of a heat map, or what this occupancy data might look like in like a retail store setting. And the slide after is the same idea in a commercial office space, where we see these heat blooms that give us an idea of which spaces are being the most utilized and which ones are being underutilized. It can be quite useful. This next slide is similar in that it looks at peak traffic areas, and again, that same commercial office space with motion trails. And if we move along to the next one, this is just another example of what a building automation system interface might look like, and how this data could be presented to the users, the owners, and the operators, and essentially make use of it in the best way that we can. So I don't know if you would like to wrap up this section real quick.
Yeah.
Kevin.
Well, I think nice work describing how it can be used. And I would say, market penetration on this is not super deep, but is interesting. And we've seen some great examples. But you can imagine how this could be part of the return to work. One of the strategies for keeping indoor environments safe, we've heard all for the last year and a half, is spatial distancing. I like to say spatial distancing instead of social distancing. But limiting occupant density in certain zones at certain times is one possible kind of hierarchy of control, if you will, from an organizational level. And this sort of situational awareness, pardon the buzzword, but just awareness of when people are using your buildings, where people are within those buildings, what does the density really look like, could help make some judgment decisions on percent occupancy, return to work, or potentially, God forbid, another pandemic or another resurgence of this pandemic maybe needs to flex in and out using these kind of data.
Great. So we'll move to asset tracking here. So asset management has the potential to optimize use of costly resources in a building, so especially space and objects. And these can be realized through this integration of LLLC features and like a wider building automation system. So looking at these two just quick examples, this is about quickly locating movable equipment. So, AV carts, wheelchairs, and other hospital equipment, along with this industrial application of locating certain equipment like forklifts. So this can also, again, be available or can support improved equipment and space usage while saving staff time as well. So in some settings, wearable devices or smartphones can also be integrated to improve awareness of employee work patterns and exposure to thermal and light conditions from their perspectives. And as Kevin mentioned earlier, demand response, again, is another strategy that we can take advantage of as a near real-time feedback from electric utilities to essentially shift the building's electricity use and avoid peak consumption, right? So we can essentially integrate that signal with LLC and BAS. And these could also be communicated with building occupants to sort of passively and maybe even actively in some ways help guide their actions and sort of try to frame automated building controls in a positive light, while also attempting to basically encourage the use of passive strategies like natural ventilation and daylighting, while reducing the energy consumption of those active systems like lights, light dimming. And one thing that I'll mention here, although this would definitely be useful, especially in an office setting, we should definitely take care that excessive control overrides and just control in general doesn't stretch the thermal or visual comfort zones too far for the occupants or for long periods of time. In that case, we might have the exact opposite effect of what we're trying to get across to the occupants. So And if you'd like to wrap this section.
Yes. So right now, the asset tracking components are kind of limited to some major assets. Here you can see hospital beds or carts in healthcare settings, or forklifts, et cetera. But I think the idea that the asset, the individual, and I know there's a privacy concern, we'll talk about some of those later, but through wearable devices, you can imagine to start to layer in more awareness of individuals' exposure to environmental information using some similar concepts as are currently being used to sort of find your office, your conference room, or find your forklift or your wheelchair in a healthcare setting, or a hospital or a senior care setting. So once we make that transition, it kind of opens up this opportunity for a better understanding of individuals' environmental exposure. And we'll start pulling on that theme a little bit more in the next sections.
Yep, thank you, Kevin. So pairing LLC and HVAC systems has been one of the most promising, we believe, and readily achievable expanded uses of the LLC technology. So most buildings have separate lighting and air handling sensing and control systems with little or no cross communication. And this is largely because of a lack of interoperability and just intention behind that interoperability. So HVAC data is often communicated through BACnet, the Building Automation and Controls Network, and it's sort of hard-coded into specific programs and applications that LLC is currently not a part of, but it certainly could be, and it could be integrated through this BACnet format, which could then provide this next level of HVAC integration to facilitate improved occupant counting and essentially take advantage of the distributed sensor network, the increased resolution of data around occupancy. So, for example, the spatial resolution of these sensors would be far more precise than present CO2 sensors for managing ventilation rate, right? And the issue here is primarily that indoor CO2 readings have this inherent lag time, which is, CO2 needs time to accumulate in the space. And this often takes from minutes to hours before elevated thresholds are reached and control systems are able to respond. So instead of waiting for these CO2 sensors, we can also integrate these motion sensors and occupant density mapping to gauge occupancy levels in near real time, if not real time, and essentially ramp up ventilation as occupants enter a space and potentially enable this predictive ventilation control instead of the reactive control that we presently rely on. Likewise, distributed temperature sensors could also be integrated for this improved overall thermal conditioning and occupant comfort. But overall, we believe that this LLC and HVAC data integration could perhaps potential to improve ventilation and thermal responsiveness compared to the standalone systems that are presently implemented.
So I think there's kind of 2 points I wanted to underscore there. One is what we could do with the current occupancy sensors and illuminance sensors to tie more integrated control of our buildings. And then the second is what we could do if we imagine the lighting infrastructure as the backbone for more distributed sensors. So basically packing more sensors onto the light fixture, right? And I can argue both sides of this from a overuse of technology perspective, and why the light fixture? Well, the light fixture just kind of happens to be a unit that is mass produced, that are put out on a grid through the space at resolution that's relevant to the individuals that use the space. So it's a piece of technology that's connected and it's plugged. You've got power, either through wired or wireless networking. You've got a communication platform, and it's got a spatial resolution that's relevant to individuals who use the building. So that's my answer to why LLC for this, as opposed to just distributing motes and sensors around every workstation or something. I suppose the other solution would be, workstation specific, but then you get into talking about, well, workstations are typically user assets, whereas light fixtures are typically owner assets. And so who makes decisions, financial decisions? And capital investments and things like that. But so those are the two things. And there's a lot we can unpack, and the paper talks a little bit more about this, but you can obviously, as soon as we start talking about ventilation and awareness of where individuals are, you can imagine there's a COVID or a pathogen mitigation overlay, right? And then the other thing that Alan mentioned there, which I think is so important, so I just want to reemphasize, is right now ventilation, our energy efficient ventilation control is CO2 based control, and those sensors have a history of drifting, and just fundamentally they lag behind. And so 20 people walk into a conference room, they breathe out a bunch of CO2 somewhere down the road, finally that's being detected, and then fresh air is being supplied, and then the people are already gone. So I think there's this really exciting opportunity to be more predictive with our control solutions for ventilation.
Great. So touching on security and safety real quick here. So there's quite a bit of potential here for LLCs to become networking backbones in buildings, right? So along with these integrated sensors and distributed sensor networks, it could certainly become a system that can facilitate integration between a variety of control systems and sensors. And this includes the native, again, occupancy and daylight harvesting sensing, but it could also facilitate emerging technologies like in-room photo-optical sensors, smartphones, and a variety of wearable devices. So, you know, cameras, for example, are already common across many space types. And the question is, can we do more with them, right? So additional applications certainly include luminance monitoring, so light availability and visual comfort, and then infrared mapping, right? So surface temperatures, motion detection, fire and smoke detection, and then potentially security monitoring. So outside of occupied hours, these occupancy sensors and these image-based sensors or existing cameras could also function to support, right, security measures and monitor for unexpected occupants during those times. So I think that's a quick overview there, Kevin, if you'd like to add to it. But
actually, I think I'll use it to just transition to the next one, which
Sure.
is, you know, Alan, you mentioned cameras, and I think everyone gets a little nervous when they start thinking about cameras in their workspaces, understandably, but I also think we need to recognize that cameras are ubiquitous. They're all over the place. And so the question really is, what can you do with them? And then what security and privacy limitations do you want to make sure are implemented such that at least there's an awareness of what's being, you know, recorded, and then maybe we can be smart with the kinds of cameras that we install to manage and mitigate some of that, and of course, cybersecurity, et cetera. But I just wanted to use that notion that perhaps we can imagine new sensors being distributed throughout our environments, and cameras being a piece of that, perhaps at a different spatial resolution. I mean, everybody who's got a smartphone's got a camera sitting on their desk looking up right now, or maybe it's in your pocket, but probably most of us have it sitting on the desk and it's looking up. That's another illuminance sensor, if we want to use it that way. Probably everybody who's staring at a laptop's got a camera staring them straight in the face. Maybe a second camera on the top of your paired desktop screen. So in my office, I have got 3 cameras staring at my space right now. And I'm not using it for anything. It's the host. Oh, sorry. Thought I was on. There's one of the cameras staring at my face. So I think the question is, what more could we do with that? And some of you know, I've done a lot of work on visual comfort, a lot of work on daylighting. And what you're seeing on this slide is actually Chris's space at the Bullitt Center. The images on the left, daytime at the bottom, a nighttime at the top, images in the middle or on the right, the colorful images, those are luminance maps. Many of you have probably heard of high dynamic range imaging that you can use with cameras to get pixel by pixel resolution of the lighting intensity, the luminance intensity from that point of view. Again, nighttime at the top, daytime at the bottom. And then the image on the right is smart facades. And in this case, it's a automated louver blind, but that could easily be a piece of electrochromics. Shout out Rob G, I see in the audience. Could be a piece of dynamic glass, right? So whatever that dynamic facade is, here's your potential is you can use these luminance-based controls, which are seeing more about what we perceive in the space, right? The illuminance sensor on the ceiling is a bad proxy for the illuminance on the desk, which is a bad proxy for what we really care about, seeing the visual field. And so potentially cameras could be integrated with a Luminaire level lighting control solution to do a better job controlling lighting. But if the integration of a smart facade or an automated facade was possible, do a better job controlling motorized blinds or electrochromics to support human comfort. And the reason that this could have a health implication, of course, is increasing access to view, and then also increasing access to circadian exposure, which we'll talk about here in a moment. But I just wanted to explain the power of a dynamic facade for a moment with this graphic. So the dashed line that really jumps up on that screen is how much illumination will be coming in that space on the east facade because the sun is baking the facade. And then the first solid line with the says performance potential range to that kind of medium-sized hump shows what happens when you close those blinds in the morning to minimize glare, and then you open them as soon as the sun's off that facade to support daylight, view, and circadian exposure in the afternoon, and the illumination jumps back up. And then what would have happened in the orange dash line or the red dash line at the very bottom in terms of indoor illumination if you hadn't opened that automated blind or dimmed up that electrochromic facade. So it's a bit of a plug for automation in systems and another layer of potential energy savings as well as visual comfort and human health. Next slide.
Thank you, Kevin. So related here to visual comfort, HDR, these luminance sensors and illuminance sensors as well, could be used in the vertical visual field for active tracking of occupant circadian dosing, and essentially provide this other layer of information that could inform controlled decisions around electric lights and automated shades, as Kevin just described. So circadian dosing, it's certainly an important factor in optimizing our body's mental and physical processes and to support restorative sleep. And again, it's most often discussed in this context of alertness, sleep, and the sleep-wake cycle. As we're seeing in this diagram, during the day, light exposure prompts the body's internal clock to send signals that keep the body awake and active. And then as we get into the late afternoon and in the evening, lack of light or this exposure to warmer light prompts the body to generate melatonin, the hormone that for humans promotes sleep. So historically, our activity, human activity, has been sort of bounded by the diurnal cycle, daylight cycle, but we now spend a majority of our time indoors conducting these visual tasks under electric lights in most cases. And research has shown that we haven't quite kept pace with those changes, or our physiological processes have not kept up pace. So blue or cool light is particularly stimulating, and exposure in the evening has been correlated with decreased quality, sleep quality. And this system has extremely consequential implications for general health, and its demonstrated effects on alertness, mood, and cognitive function, right? So the detrimental effects are felt by the industry as well and by organizations worldwide. So economic losses are estimated to exceed $400 billion annually in the US alone. And if we jump to the next slide here, if we're looking at how do we actually get at this data, so tracking circadian dosing could be implemented through these workstation specific sensors, so or wearables essentially, and programmed to communicate with the LLC system wirelessly, right? So they could be implemented as part of the furniture around our offices, we could certainly start using some of these cameras that Kevin already described that we have around us, basically at all times. And illuminance sensors could also be used that are in the existing LLC fixtures as sort of this basic indoor circadian dose mapping tool as well. So
I just wanted to underscore a couple things. And I think probably a lot of people have heard about the potential for lighting to implicate circadian regulation in humans. And on one hand, I don't want to detract from that value and that importance, because I think it really is. We spend 90% of our time indoors, so clearly the lighting exposure we get in our indoor environments absolutely matters, especially in winter hours, when that's about our the time we spend in buildings is the time the sun has come up and already gone back down under the horizon. So I don't want to underemphasize it, but I also want to put a little more emphasis on the role of daylighting within that equation. And from an LLLC standpoint, to say, look, it's still important, because I think daylight exposure, a lot of what we're talking about, we could be using asset tracking to understand humans' exposure to daylight, and then maybe guiding hot desking solutions or conference room choices around spaces that are better daylit. We could be using the onboard illuminance sensors in Luminaire Level Lighting Control to understand what are the best daylit spaces in our building over the course of the year, and guide those and prioritize those spaces either for communal functions like conference rooms or break rooms, so that everybody gets some access to those spaces, or again, from a prioritization and a hot desking perspective. But then also the backbone that LLLC is from an integrated controls, has this integrated controls potential. And what I see as a trend toward more advanced facades, where facades and lighting and HVAC can be integrated to, in this case, also support increased access to daylight and view. And then finally, I would say, let's not forget the value of extracting the blue light out of the illuminance, electrically provided illuminance equation in the evening hours is a bit of a mental cue from an office worker standpoint about thinking about, shifting to warmer light sources in the evening. But also remember that there are a lot of 24-hour facilities, dorms, assisted living, senior care centers, hospital environments. There's a huge opportunity for managing and removing the blue light spectrum from fixtures, especially if they're truly spectrally selective and can remove certain wavelengths, as opposed to just kind of shifting the color temperature, but keeping the blue enriched wavelengths in the equation. So I wanted to emphasize a few of those points. And I think Alan's going to wrap us up.
Yep, getting there. So that completes our list of these use cases that we wanted to touch on. And we'll move to sort of just quickly touch on the applications as they apply across different space types, right? So the modularity of these systems, the LLC systems, these sort of decentralized per fixture sensors, offers quite a bit of flexibility, right, on the installation and operation side, particularly through the lighting retrofits at a lower cost than typical lighting redesigns, again, which makes them advantageous in quite a few different space types. So these systems could be leveraged to sort of simplify and standardize lighting designs and layouts in a wide range of commercial and education space types, right, that don't often have access to a lighting designer. So this could be open offices, private offices, conference rooms, classrooms, and common spaces and circulation corridors in most cases. And just to touch on healthcare and senior living could greatly benefit from some of these novel attributes that we're trying to suggest here. And examples of that include automated lighting controls that can support wayfinding and reduce risk of falls at night, and basically management of blue light that could also help support sleep and circadian health are great examples. Occupant and asset tracking can be useful for healthcare personnel to essentially keep track of mobile patients and residents in senior care or other healthcare settings. And of course, expensive equipment, right? Wheelchairs, diagnostic carts, etc. And the idea here is that pairing big data about human health outcomes with big data about relevant environmental parameters, together with objects in space, can help support these sort of improved health outcomes while avoiding higher risk building operation strategies, right? So if you'd like to add to that, Kevin.
No, I think it's great. In fact, just the transition to the challenges, and the first one that Alan mentioned there is this really great opportunity to understand human health data and building environmental data like we have never before. But the obvious question there is HIPAA and privacy, and so I think the transition is useful. Alan's going to unpack a few of these challenges, and then we'll roll it into Q&A.
Sure. Yeah. So we can start with building system integration here. So one of the more significant challenges, technical challenges, that currently limits this potential of these systems is again, this lack of a universal data format and language, which sort of introduces a lack of interoperability across sensors and systems, right? So most of these products on the market keep their data and controls in sort of this proprietary black box that can't be accessed directly without modification of the hardware or software. Looking at the privacy and security side, privacy concerns are certainly becoming more relevant and could certainly hinder some of these potential future applications. And there are justified worries about, again, the proliferation of cameras in the public sphere. Right. So security also comes along with that, especially since we could have image-based sensors and cameras that could provide unintentional access into some of these potentially sensitive spaces, not implemented correctly. But again, these risks could be avoidable by prioritizing robust cybersecurity in the BAS and LLLC networks. And additionally, you could have low resolution or AI modified data that could potentially address those concerns. So we could degrade the data in a way to where even if it is breached, it would not actually provide any useful information or identifiable information. And this last one, just to touch on data and API, this is, again, the idea of these systems acting as a network backbone in buildings. Again, the onus is mostly on the manufacturers to develop and agree upon the standardized interface with certain tools that could enable developers of these third-party IoT devices to make their devices compatible with LLC networks. So I think I'll leave it there, Kevin.
Good.
Yeah, so thanks, Alan and Kevin. Really appreciate it. Thanks for sharing your expertise. Your talk has elicited a lot of questions from our audience. Excuse me. And so I want to get started getting them answered. And pardon me, they range from the incredibly geeky to the pretty general. So let's start with a general one. The first question is, if you as a designer are interested in doing more integration with your lighting system, what is a good first step?
Well, I would say the first question was, are you talking new construction or existing building retrofits? And in either case, the question is, well, what's your HVAC building automation system platform, and what's your plan for your Luminaire Level Lighting Control or lighting control platform? And really, you want to start asking questions about the interoperability of those two. The good news is there are several organizations, companies that have been kind of conglomerating, if you will, and now have all of that in-house. I'm not going to name names, but there are multiple organizations that are doing building automation system control for HVAC systems, as well as Luminaire Level Lighting Control, and they've had a few years now to start to work out some of those interoperability issues. And from a hitting the easy button perspective, that might be a way to go. But at a minimum, you're going to have that conversation right out the gate about interoperability and learn what is easy and what is potentially achievable.
So another another question came in asking about case studies for space utilization and optimization. I know you showed some images there, and there was another question that brought up a project that I'm familiar with called the Edge, which is a Deloitte project in Holland. And that question was, how is LLLC different from their use of a power over Ethernet LED connected lighting system that is paired with sensors that kind of transmit energy data and energy management to a central control system. So I'm kind of putting those two together, hoping you can maybe give some examples of some places to look for example projects, and maybe comment over on the power over Ethernet and its relationship to LLLC technology.
Well, I'll give the brief answer to both. The most common utilization that I've seen of kind of space utilization is find the conference room. There was a company, and again, I'm going to avoid naming names, that was originally just doing sort of comfort assessment, and then also started layering in where's the nearest available conference room, and now that's been all integrated into one other company that's doing HVAC and lighting. So there's quite a lot of examples of buildings that have used those techniques to find a conference room or find a hot desk. As far as more advanced uses of that, I'd be making estimates, or I'd be making a guess, so I'll refrain from that. And as far as the Edge goes, I think it's a really similar concept. I won't say that I've studied the Edge in great detail, but from what I have read about it, and what I know about LLLC, I'd say the concepts are similar. It's more just the way it's being executed, the communication protocols that are different. The devil or the angel, I don't know which, might be in the details there, because the communication is really important, and getting these data streams to weave together is a big piece of the work to make any of this possible. So I don't want to underemphasize the potentially meaningful differences of those communication platforms.
One thing I'll add in is that the General Services Administration recently published a case study that they did on one of their newer buildings in DC, where they did space optimization using distributed sensing. I'm not sure the extent to which that happened with the lighting, but that's a source for the person who asked the question. Maybe I'm going to direct one to Alan, because I know, Alan, you've done a lot of research in sensing. One of the questions was, what research needs to happen to better understand how sensors at the light fixture can better predict thermal comfort or visual comfort, and how is that different from sensing, in different locations? Or do you have general thoughts on sensing optimization at the fixture level?
Yeah, definitely. I think the thermal sensing would definitely, I think we would still need to do a bit more research on accuracy, right? So placing the sensors in the fixture, which would give you sort of this stratified, potentially a view of what the ceiling looks like, but not necessarily what's happening down at the occupant level. So that's certainly an issue. And we could look at how accurate or good of a proxy it could be, but we're not sure of that just yet. On the visual sensing piece, certainly looking at ceiling mounted horizontal illuminance or even luminance would not be the most ideal proxy for how we experience light when we're actually sitting and looking at a vertical screen or vertical backgrounds like walls around us, windows, etc. So it certainly wouldn't be ideal, and we always try to find what's the best way that we can position luminance sensors and potentially even illuminance sensors that would be closest to an occupant's field of view, or what they're seeing, what they're receiving as far as a vertical light is concerned, right? So this could take the form of wearables that could be placed as close as you can to an occupant's eye, right? So it might be or become part of your glasses, for example, or something that you can simply wear on your person, on your torso. And that would give you a much more accurate assessment of how much light you're receiving during the day, and it would stick with you, right? So it would move with you. The sensor could move with you. Looking at the HDR sensors, that's a little more difficult because motion is always difficult when you're trying to capture multiple exposures over a period. So trying to position fixed cameras, again, like we mentioned, potentially in furniture-based sensors, something like that, or existing cameras that that are already integrated into our equipment, like laptops, would certainly be a way to go. But I think we would still need to do a bit more research on how accurate that could be and how we could turn it into a better proxy, essentially. So I think that'd be my thought on the matter.
Thanks, Alan. So I'm going to shift gears a little bit. We had a really specific question on the Seattle Energy Code, but maybe what I will do is first ask Kevin and Alan about can LLLCs be used to fulfill energy code requirements for lighting controls?
I believe they already are. The IBC does already have a pathway for LLCs to satisfy it, but I'm not sure of the details. I'm not sure if you are, Kevin, or how.
I think Chris should answer the question about Seattle.
Okay.
I'll definitely take the Seattle question. I know that there's an IBC path that allows you to use LLLCs and automatically deems code compliance simply for the use of a qualified product. But the question that we received for those of you in Seattle, and our code is pretty geeky and getting tough. Do LLLCs fulfill the Seattle Energy Code requirements for enhanced lighting controls under the C406 Enhanced Energy Efficiency Measures pathway? And the answer is resoundingly yes. So if you use an LLC product that is qualified as LLLC, it will meet every requirement of that enhanced digital control overlay. So that's an easy one, and really in a lot of ways an easy button for a code compliance with that particular statute. Other question, Kevin, you touched on this a little bit, but maybe you could elaborate. How can lighting controls help facilitate the entrainment of circadian rhythm, and how should designers be thinking about that when thinking about their lighting system?
Well, I would say one of the more often forgotten pieces about circadian entrainment is darkness at night. And so turning off lights, but darkness at night is really important. And then as you're approaching sleep, you want to remove the blue wavelengths. So the warmer shift, either warmer shift by removing the blue spectrum, or just white balance warmer shift as a kind of cue, but then dimming so that you get a total reduction of intensity. Those are both ways that I think a Luminaire Level Lighting Control system that sort of isn't integrated with a automated facade, for example, can be helpful. There's some evidence for a kind of alertness by increasing the blue wavelengths during the morning or increasing the intensity. But I think what you really have to remember there is most electric lighting fixtures are like an order of magnitude or multiple orders of magnitude lower in intensity than the daylight source that's sitting outside. And really it's about getting views to the outside and getting the daylight inside to allow the retina to get the illuminance that's needed to really spike a healthy sleep-wake cycle on the other side of the coin. But I would say dimming at night and shifting to the warmer, hopefully evacuating the blue wavelengths if possible through true spectral tuning is a great idea.
Yeah, so we are right about time. Thank you so much, Kevin and Alan, for your presentation. And thanks again to all the participants for joining us today. We really appreciate it. If you're interested in learning more, please visit the link on the chat and on the now on screen. Again, as a follow-up, we'll be sharing the recording, the slides, and a white paper via email with all the attendees of this webinar. So when you exit, you'll be directed to a short survey, and we hope you will take that regarding your experience today. We really appreciate your feedback. And thanks again for attending, and have a great rest of your day.
Thanks, Chris. Nice to see you all virtually.
Thank you all.
Bye, everybody.